My name is Emma Cutler, and I am a System Dynamics Analyst with IISD. And I'm going to be talking about our results of a sustainable asset valuation for nature-based infrastructure in the city of Tshwane, South Africa. So the city of Tshwane is facing several climate challenges. Specifically, urban heat islands are a problem that are projected to get worse as temperatures warm. Also, stormwater runoff is a large problem in the city, and this is also projected to get worse, primarily due to the loss of impervious surfaces as the city continues to develop, as well as stormwater infrastructure that is deteriorating. So for our assessment, we used a case study location of the Rainbow Junction development, which is a new mixed-use development in Tshwane. And this development includes 35 hectares of open space, and there's a stream running through it that they're rehabilitating. So this is a development that's already focused on incorporating nature, and we were going to be looking at how we might be able to incorporate more nature-based infrastructure into Rainbow Junction. So the goals of our SAVI assessment are to quantify the costs and benefits of incorporating additional nature-based infrastructure into Rainbow Junction. We also want to evaluate the potential for nature-based infrastructure to mitigate urban heat islands, and to reduce stormwater runoff, and in general, increase climate resilience in Tshwane. And then finally, we want to identify the impacts of climate change on services provided by the urban green spaces that we assess. Specifically, the nature-based infrastructure that we used in this assessment were green roofs, which we define as any roof that's covered with soil and is used to grow plants. Broadly speaking, there are two different types of green roofs. There are extensive roofs, which are very thin and lightweight. These are usually used to grow grasses and mosses and are typically very low maintenance. This is in contrast to what are called intensive green roofs, which are much thicker, and so they can support many more plants and can even function as rooftop gardens or parks. And regardless of the type of green roof used, these roofs sequester carbon in the vegetation. They can also retain rainwater in the soil, and they insulate the building below while also mitigating urban heat islands. The second type of nature-based infrastructure that we used in this assessment were street trees. So these are trees that are planted along the edges of roads. They are separate from parks or other open spaces, and this can include any type of tree that is planted in the city. Like green roofs, trees sequester carbon as they grow. They can intercept and store rainwater both in the plant biomass and also in the soil that they're used to grow. And trees provide shade for nearby areas, which can mitigate urban heat islands. For this assessment, we looked at three different nature-based infrastructure scenarios. The first was looking at just a single green roof that would be installed on one building. And these results can be used by property owners or developers to look at the impact of choosing a green roof instead of a conventional roof. The second scenario that we looked at was if 67,000 square meters of green roofs are installed in Rainbow Junction. And this represents 10% of the roof area in the proposed development. And so these results can be used to evaluate the impact of green roofs on a larger scale. And the third scenario that we looked at was considering if 1,000 street trees are planted in Rainbow Junction. And so we're assuming that these trees will be separate from the 35 hectares of open space that are already planned for Rainbow Junction. And the key findings from our assessment are that green roofs and street trees can reduce stormwater runoff and reduce energy requirements for cooling and store carbon. So in this way, they're able to meet those needs that the city of Tshwane is facing right now. In particular, we see that green roofs have a benefit to cost ratio of 1.21, and street trees have a benefit to cost ratio of over 31. And so this tells us that both are economically viable investments in the city of Tshwane, and street trees in particular could generate significant value. We also found that the value of green roofs and street trees will likely increase as climate change causes warming and more extreme precipitation in the city. And so this really tells us that nature-based infrastructure in the city of Tshwane can contribute to climate resilience. And these results can be used by many different types of stakeholders. For local government, they can inform climate adaptation plans and strategies that address stormwater runoff and urban heat islands. And they provide evidence that nature-based infrastructure can provide benefits at the city scale. Project developers can use this assessment to inform decisions about constructing nature-based infrastructure in new developments. And it demonstrates that incorporating NBI provides value to city residents and businesses and provides motivation to include nature in these new urban developments. For the national government, the assessment can help to define standards and regulations for including NBI in new development projects. And for donors and investors, our results provide quantitative evidence that nature-based infrastructure is economically viable. And the assessment can help to define funding priorities for infrastructure investments in the future.